हाय किड्स, इस वीडियो में हम लोग न्यूमेरिकल्स करेंगे क्लास 10 कंसाइंस फिजिक्स चैप्टर 1 फोर्स। तो चलिए शुरू करते हैं। सम नंबर 1, द मोमेंट ऑफ फोर्स ऑफ 10 न्यूटन अबाउट अ फिक्स पॉइंट O इज 5 न्यूटन मीटर। कैलकुलेट द डिस्टेंस ऑफ द पॉइंट O फ्रॉम द लाइन ऑफ एक्शन ऑफ फोर्स। सो हमें क्या क्या दिया हुआ है? मोमेंट ऑफ फोर्स हमें दिया हुआ है 5 न्यूटन मीटर, फोर्स हमें दिया हुआ है 10 न्यूटन, दोनों ही एसआई यूनिट में है, देयर इज नो प्रॉब्लम। कैलकुलेट द डिस्टेंस ऑफ द पॉइंट O फ्रॉम द लाइन ऑफ एक्शन ऑफ द फोर्स। थोड़ा सा फॉर्मूला याद रखिए। फॉर्मूला क्या था? मोमेंट ऑफ फोर्स जो होता है दैट इज इक्वल टू प्रोडक्ट ऑफ फोर्स एंड परपेंडिकुलर डिस्टेंस of the force from the point O. Now, moment of force is given as 5, force is given as 10. मान लो perpendicular distance x है, so 5 by 10 is 0.5, so x is what? 0.5 meter, which means the distance of the point O from the line of action of force is 0.5 meter. Just formula याद रखने से ही हो जाएगा. Now look at the second one. Now look at number 2. A nut is opened by a wrench of the length 10 centimeter. If the least force required is 5 Newton, find the moment of force needed to turn the nut. तो wrench कुछ इस प्रकार का होता है, कुछ ऐसा होता है wrench, ऐसा ना। आप क्या करते हो, यहाँ पे नट जो आपका है, यहाँ पे नट को आप लगाते हो रेंच के इस साइड से और फिर इसको टर्न करते हो, तब ये नट खुल जाता है, इट ओपन्स। ना दिया हुआ है ये जो रेंच का लेंथ है वो है 10 सेंटीमीटर और यहां पर जो फोर्स लगा रहे हो आप वो है 5 न्यूटन। तो मोमेंट ऑफ फोर्स क्या होगा? वेरी इजी। मोमेंट ऑफ फोर्स अभी अभी किया फर्स्ट सम में, it is the product of force multiplied by perpendicular distance of the force from the point O. This is your point O in this case. The length is 10 centimeter perpendicular distance. So this will be 5. SI unit है, तो सेंटीमीटर को अगर मीटर में करेंगे तो 10 by 100. So that's 50 by 100, isn't it? 5 by 10, that's 0.5 Newton meter. This is the moment of force needed to turn the nut. Clear hai? Now let us look at the next one. Now look at number 3. A wheel of diameter 2 meter is shown with axle at O. A force F equals 2 Newton is applied at B in the direction shown in the figure. Calculate the moment of the force about the center O and about the point A. पहले हम लोग center O को देखते हैं. About the center O. Now look carefully. This is your radius, which is 1 meter because the diameter is 2 meter. So when they are asking the moment of force about the center O, the perpendicular distance of the force from the point O is 1 meter, which means moment का formula क्या था? Moment of force is force multiplied by perpendicular distance, और इस केस में फोर्स तो आपका 2 न्यूटन है और परपेंडिकुलर डिस्टेंस कितना है? 1 मीटर, मतलब 2 न्यूटन मीटर। और डायरेक्शन क्या होगा? देखो ये व्हील है आपका, दिस इज द व्हील, तो ये ऐसे रोटेट करेगा जब यहां पे एक फोर्स लगाएंगे तो, मतलब क्लॉकवाइज, isn't it? दूसरा देखते हैं, अबाउट द पॉइंट ए। द पॉइंट ए, जब आपका पॉइंट चेंज हो रहा है, मतलब देन द डिस्टेंस ऑफ द फोर्स फ्रॉम दैट पॉइंट इज इक्वल टू द डायमीटर विच इज इक्वल टू 2 मीटर। इस केस में आपका परपेंडिकुलर डिस्टेंस क्या है? 2 मीटर। सो मोमेंट ऑफ फोर्स क्या होगा? सेम, फोर्स इंटू परपेंडिकुलर डिस्टेंस। फोर्स क्या है आपका? 2 न्यूटन and perpendicular distance is 2 meter, so this will be 4 Newton meter. Again the force is applied in this direction, it will move the wheel clockwise. So same clockwise ही होगा direction. Am I clear? So about the center O is 2 Newton meter clockwise, and about the point O it is 4 Newton meter clockwise. Now let us see the next one. Now look at number 4. The diagram shows two forces F1 5 Newton, F2 3 Newton acting at point A and B of a rod pivoted at a point O such that OA is 2 meter and OB is 4 meter. Calculate the moment of the force F1, about O. Very easy. This will be force into perpendicular distance of the force from the point O, which is what? Force is 5 Newton and distance is 2 meter. So that's 10 Newton meter, and this will try to turn it in this direction, anti-clockwise, isn't it? Now the second one, the moment of the force F2 about O, this force, it will try to turn the rod like this. Okay, so this is again force into perpendicular distance. In this case force is 3 Newton, perpendicular distance is from the point O 4 meter, so that's 12 Newton meter, and if you see the direction will be clockwise, isn't it? Total moment of force, so the total moment of force, see, this is anti-clockwise, this is clockwise. Moment of force F2 about O is greater than moment of force F1 about O. So the resultant will be what? 12 minus 10, which is 2 Newton meter clockwise. Isn't it? That will be the total moment of the two forces about O, because the direction is opposite. One is anti-clockwise, one is clockwise. So the resultant will be 2 Newton meter clockwise. Clear? Now let us look at the next one. Now look at number 5. I'll just read the sum. Two forces, each of magnitude 10 Newton, act vertically upward and downward respectively at the two ends A and B of a uniform rod of length 4 meter, which is pivoted at its midpoint O, which means this distance and this distance will be same. O is the midpoint. As shown in figure, this one, determine the magnitude of the resultant moment of force about the pivot O. Very easy. Look over here. Suppose this is F1. This is F2. So moment of force due to F2 about O will be force into perpendicular distance. Force is 10 Newton. Perpendicular distance is, the total length is 4. O is the midpoint. So this is 2 meter. So that's 2 meter. That's 20 Newton meter. And this will try to move the rod like this clockwise. So this is clockwise direction. Clear? Now, moment of force due to, sorry, this was F1 I have taken, F2. That's again force into perpendicular distance. That's 10 multiplied by, again the perpendicular distance is 2 meter. So that becomes 20 Newton meter. Again, this will try to turn the rod clockwise direction. Now both have the same direction, which means the resultant moment of force will add these two, the sum of these two. That's 40 Newton meter clockwise. That is your total moment of force due to this F1 and F2, which was same 10 Newton each. Done. Now let us see the next one. Now look at number 6. This figure shows two forces, each of magnitude 10 Newton, acting at the point A and B, okay, at a separation of 50 centimeter in opposite direction. You can see the figure. Calculate the resultant moment of the two forces about the point A. First thing, about the point A. Now look carefully. About the point A, due to this force, moment of force about the point A due to this force will be force into perpendicular distance, that is 10 into the perpendicular distance is 50 centimeter, which in meter will be 50 by 100, so that's 5 Newton meter, and this will be clockwise if you look carefully, isn't it? Now about the point A, what will be the moment due to this force? It will be 0. Why? Because the perpendicular distance is 0. Done. So this will be your answer, 5 Newton meter clockwise. Now they have told about the point B now. Number 2, about the point B. So when we talk about this point, when we want to find the moment of the force about the point B, then moment of force due to this force, this force I'm talking about is force into perpendicular distance, which is equal to 10, again into perpendicular distance is 50 centimeter, that's 50 by 100 meter, that's again 5 Newton meter, and this will try to turn it clockwise, so it's clockwise direction. Done. Again, moment of force about the point B due to this force will be 0. Why? Because the perpendicular distance is 0 between the point of application and the force. Now what they've asked, calculate the resultant moment of two force about the point A, B. Number 3, O. Number 3 is O, situated exactly at the middle of the two force, which means this will be 25 centimeter, this will be 25 centimeter. So at the point, about the point O, we'll first find moment due to this force. Moment will be force into perpendicular distance, which is 25 by 100 Newton meter, which is 5 times 5 2 times, that's 2.5 Newton meter, and that will be clockwise. Am I correct? Then again, moment due to this force, will be force which is 10 into perpendicular distance, that is 25 by 100, 0. Again, that's 2.5 Newton meter. This is also clockwise, which means the resultant moment will be, you'll add these two because both are clockwise, so 2.5 plus 2.5 will be 5 Newton meter clockwise. Done. So about the point A, 5 Newton meter, about the point B, 5 Newton meter, about the point O, again same answer, 5 Newton meter clockwise. Done. Now let us see the next one. Now look at number 7. A steering wheel of diameter 0.5 meter is rotated anti-clockwise by applying two forces, each of magnitude 5 Newton. Draw the diagram to show the application of forces and calculate the moment of the force applied. First of all, draw the diagram. Suppose this is your steering wheel pivoted at O. This is the diameter, which is 0.5 meter, you apply force, suppose here anti-clockwise, it moves the steering anti-clockwise 5 Newton, and over here again 5 Newton, it moves the body anti-clockwise, the steering wheel anti-clockwise. This is the diagram. What they have asked, draw the diagram to show the application of forces. Done. Calculate the moment of the force applied. Now look carefully, this is O, this is A, this is B, suppose. Now this is the clear case of couple. What was couple? Just remember, two equal and opposite forces, two equal and opposite parallel forces not acting on a same line, on the same line. That is your couple, isn't it? And remember, in this case the moment of force applied will be nothing but moment of couple, which is either of the force multiplied by perpendicular distance between the two forces, which means between the two forces. So what is it? Either of the force is 5 and distance between them is 0.5. So that is 2.5 Newton meter, and moment of couple in this case is nothing but the total moment of the force applied. Because see, if you do it separately, you will get the same answer. See, moment due to this force is 5 multiplied by, this is how much? This is 0.25 radius, 0.25, which is equal to 1.25 Newton meter, and moment due to this force at B, moment will be force into perpendicular distance from O, where it is pivoted, that is again this is 0.25, so that's 0.25, which is 1.25 Newton meter. Now this and this both are anti-clockwise. When you add them, 1.25 plus 1.25 will be 2.5 Newton meter. So total moment of couple or the moment of the force applied in this case is 2.5 Newton meter, of course anti-clockwise. Done? Clear? Now let us look at the next one. Now look at number 8. A uniform meter rule, which means this is 0 centimeter, this is 100 centimeter, meter rule, 1 meter rule, is pivoted at its midpoint, which means it is pivoted balanced at its midpoint, which means this distance is 50 centimeter, and again this distance is 50 centimeter. Now, a weight of 50 gram force is suspended at one end. Suppose over here you suspend a weight W1 as 50 gram force at one end. Where should a weight of 100 gram force be suspended to keep the rule horizontal? Of course, we need to place the weight on this side, because this weight will try to rotate this anti-clockwise. So we need a clockwise moment over here. So what I'll do, suppose I put a weight over here, W2, that's 100 gram force at a distance x from where it is pivoted. We need to find this x. Now according to the principle of moment, we know a body in equilibrium, the sum of anti-clockwise moment, will be equal to sum of clockwise moment, isn't it? Then the body is in equilibrium, sum of clockwise moment. They told us the rule is horizontal, it's in equilibrium. Now, if you look carefully in the diagram, this weight will produce an anti-clockwise moment, which will be equal to force multiplied by the distance, that is 50. Due to this weight, there will be a clockwise moment, isn't it? This will try to rotate clockwise. So over there, the moment will be force multiplied by the distance, which is x in this case. So what is x? X is 25 centimeter, which means a weight of 100 gram force should be kept at a distance of 25 centimeter from the point of where it is pivoted, on the other side. That is my answer. Clear? Just remember, the clockwise moment and the anti-clockwise moment is same. Now let's look at the next sum. Now look at number 9. A uniform meter rule. There is a uniform meter rule. This is 0. This is 100 centimeter. Balances horizontally on a knife edge placed at the 58 centimeter mark, which is, it is not balanced at the midpoint. It is balanced at 58 centimeter mark. Now remember one thing before doing the sum. If the meter rule, which is uniform, of course this meter rule is uniform, is not balanced at its midpoint, then the weight of the meter rule acts from the midpoint, which means suppose this was this point is suppose 50 centimeter. Then the weight of the meter rule W will act downward. This weight is the weight of meter rule. If it is not balanced at its midpoint, then the weight of the meter rule acts from the midpoint. Remember this point. Now, a uniform meter rule 0, 100 centimeter. Balances horizontal. Now this is balance on a knife edge. This is a knife edge at the 58 centimeter mark when a weight of 20 gram force is suspended from one end. Of course, see, if you don't keep anything over here, in this particular situation, this meter rule will rotate anti-clockwise because of the weight of the meter rule. If you don't balance it in the middle, what happens? This will rotate like this, isn't it? Which means you have to place something over here so that it is in horizontal position, it is in equilibrium. What they have done, they placed 20 gram force from one end. So of course this end they are talking about, this end they place a weight of 20 gram force. Now this is balance, they told. There's no other weights. Now in order to keep it balanced in a horizontal position, the anti-clockwise moment due to the weight of this meter rule and the clockwise moment due to the weight of 20 gram force has to be equal according to the moment principle of moment. So over here, see, your anti-clockwise moment is what? W, suppose W is the weight, multiplied by the distance. What is the distance? Distance is 8, 58 minus 50. This much is the distance, which is 8 centimeter. And clockwise, if you see, clockwise moment, this is weight is 20 multiplied by this distance, from where it is pivoted. This is 58, this is 100. So 100 minus 58, that's 42. So the distance is 42. Now anti-clockwise moment and clockwise moment will be same, isn't it? So W multiplied by 8 will be equal to 20 into 42 for 5 times, for 2 times, to 1 times, 21. So weight is equal to 105 gram force. That's your weight. Over here, if you want to write the unit, anti-clockwise moment, it will be gram force centimeter, isn't it? Over here also, gram force centimeter. And according to the principle of moment, we know anti-clockwise moment and clockwise moment will be same. So just substitute and get the value of W, which is the weight of the meter rule, 105 gram force. Done. Now let us look at the next sum. Now look at sum number 10. The diagram shows a uniform bar supported in the middle, because from here to here the distance is 50 centimeter, of course. From here to here it is 50 centimeter. A weight of 40 gram force is placed at a distance of 40 centimeter to the left of the point O. How can you balance the bar with a weight of 80 gram force? First of all, ये जो वेट है क्या करेगा, इसे इस तरह से रोटेट करेगा, क्लॉकवाइज रोटेट करेगा ड्यू टू दिस 40 ग्राम फोर्स वेट. इसको बैलेंस करने के लिए हमें यहां पे एक वेट डालना पड़ेगा दैट साइड, क्लॉकवाइज मूवमेंट, ताकि वो बैलेंस हो जाए ना. मान लो ये भूल जाओ, मान लो एक वेट था, दिस इज 80, वो मैंने कहीं पे डाल दिया. आई डोंट नो द डिस्टेंस, ये डिस्टेंस मुझे नहीं पता है, वही तो मुझे निकालना है. ये 80 ग्राम फोर्स मैंने राइट साइड में डाला, ताकि इसके कारण जो मूवमेंट होगा वो इसको क्लॉकवाइज घुमाएगा. सॉरी, दिस इज एंटी क्लॉकवाइज, है कि नहीं, और ये इसको क्लॉकवाइज घुमाएगा, तभी तो बैलेंस होगा, तभी ये हॉरिजॉन्टल रहेगा. सो यहां पे इसके कारण मोमेंट क्या होगा, क्लॉकवाइज 80 इंटू एक्स, और इस वेट के कारण एंटी क्लॉकवाइज मोमेंट क्या होगा, ये आपका क्लॉकवाइज होगा. ये आपका एंटी क्लॉकवाइज मोमेंट क्या होगा, 40 इंटू द डिस्टेंस विच इज 40 ग्राम फोर्स सेंटीमीटर, ऑफ कोर्स ग्राम फोर्स सेंटीमीटर, this is also gram force centimeter. Now both will be equal in equilibrium according to the principle of moment. Anti-clockwise moment and clockwise moment दोनों same होगा. So 80 into x is 40 into 40, one time, two times. So when you solve it, you get 20 centimeter, which means where will you place 80 gram force? At a distance of 20 centimeter on the other side from the point of where it is pivoted on the other end, isn't it? How can you balance the bar with a weight of 80 gram force? By placing the weight 80 gram force on the other side at a distance of 20 centimeter from O. It will be balanced. Am I clear? So in this video, keep it till here. In the next video, we'll look at the rest of the sum. Till then, take care and be safe. And if you like the video, do subscribe the channel.